Pre-calc, this is day 2 of 7.2. So we can finish up worksheet number 3. More proving, working with one side to make sure it looks like the other side. What side looks more complicated? The left. So, hey, wait a minute. That is a subtraction of cosine angles. So therefore, we know how to switch that out. What would that look like? Cosine pi over 2. Cosine u. Keeps or changes? Is it? What's the formula for the cosine subtraction?
Cosine plus sine.
We're going to ignore the negative on the u and change it to keep that positive because it's the value. So it's plus sine pi over 2 sine u. Question is, what's the cosine of pi over 2? We don't know cosine u. What's the sine of pi over 2? Don't all answer at once. Sine of pi over 2, 1. 0 times anything is, so that's gone. And 1 times sine u is sine u, which equals the sine u from above. Check. We just proved that the co-function there, co-identity, works. On your worksheet, you have a few of those. So it's basically using the addition or subtraction formulas, expand it, work it out, you find out that it works out just fine. Any questions? The next one, you have 1 plus tangent of x over 1 minus tangent of x equals tangent of pi over 4 plus x. It almost seems like maybe the left side's more complicated than the right side, but then you're thinking, wait a minute, if you kind of remember that tangent of a sum or that difference turns into a fraction when you switch it, right? So maybe we should work with the right side instead of the left side. Where do you guys want to start? What's that? I'm leaning towards the right. Because if you remember, what's the formula for when I expand this thing? The signs change on top and bottom, which would reflect something like that over here. But we also know that it happens to have something like tangent times tangent in there. But one of these is pi over 4 and tangent of pi over 4. Just that forward thinking. All those different things that you guys need to know or kind of remember that before you start making too many moves, start thinking, how would this affect the problem? Let's go back real quick to the very beginning. This was the addition, if I remember correctly, that problem. Or was it subtraction? I'm not sure. But either way, it's tangent of the first one plus the tangent of the second over 1 minus tangent of the first, tangent of the second. So therefore, and if it's different, the sign on top is always the same, the one on the bottom switches. I think this might be the best option to go. I'm going to switch to the right-hand side. Because now this becomes 1 plus tangent of pi over 4 tangent of x, bless you, over, alright, was that supposed to be the bottom? I might have messed that up. Sorry, that was the bottom of it. It should be tangent of pi over 4 plus tangent of x over 1 minus, because the signs are opposites of each other, tangent of pi over 4 tangent of x. But like I was saying before, when we were looking at this and trying to evaluate things, hey, wait a minute, what is tangent of pi over 4? Tangent of 45 degrees. It's going to be 1. So this ends up equaling 1 plus tangent of x over 1 minus 1 times tangent of x. And doesn't that 1 times tangent of x equal then the left-hand side over there? So you get 1 plus tangent of x over 1 minus tangent of x. And that equals a check mark. If f of x equals sine of x, show that f of x plus h minus f of x all over h is equal to the sine of cosine of h minus 1 over h plus cosine x times sine of h over h. I see that we need to add something here. There should be an x after sine. So sine of x times the quantity, not sine of that parentheses. That parentheses is its own thing. Two functions being multiplied. Okay? Should be sine of x times that quantity. If I see this problem and I ask you which side's more complicated, you probably would say, hey, the right-hand side looks more complicated than the left, right? But here's the thing. On the left-hand side, which is this thing, it's missing the fact that you're calling f of x sine of x. So this side still needs to be expanded or put together. There's almost no way to make this side look like function notation without having the function in it. So in this case, I'm going to work with the left-hand side and the fact that f of x is sine of x. So what does it mean to be f of x plus h, though? Doesn't that mean to be sine of x plus h minus sine of x all over h? Can we expand or do anything with this problem? We should be able to. I've got an addition of sine, and that addition of sine would be sine x cosine h plus cosine x sine h minus sine of x all over h. Just using expansion, right? So, how are we getting some of this stuff? They want sine of x times cosine of h minus cosine of h minus 1 all over h. It almost seems like they have a common denominator. If you think about this a little bit more, does it matter that the h is underneath the cosine h minus 1? Could I actually move it underneath the sine of x? Or would you guys be okay with the fact that it really is a really big fraction bar, right? So does that help us say, hey, if I can make something like that happen, I can maybe just kind of skirt the h to one side or the other? I don't know, is that the right wording? Skate it to one side or the other? I don't know. Okay. So, what do you guys want to do? What if there are a little craziness going on here? Look at this. Cosine of h minus 1. And it has a secant on, sign on the outside. If I was to distribute this in, wouldn't that be a sine cosine minus a sine? Do we have something like that here? A sine, cosine, minus sine? So what they're trying to say is, hey, what if I put those things together? So let's do a little bit of rearrangement. Oops. Cosine x, sine h. All of this is over h. Really, what they're doing there is not really hiding too much. They're just rearranging the deck chairs here. They rearranged, and then they said, hey, wait a minute. If I put a set of parentheses around that, can I factor something out of that group? Yeah. You can take a sine, which leaves you with the cosine h minus 1. Over here, do the exact same thing, but this time they want a cosine out. Well, that's not too bad. That's just cosine, not h, but x times sine of x. Is that legit? Is that okay? It means the same thing as I got the line above, which is the line above that. Just remember, all of these things are divided by h. But that means I've got two separate groups that are divided by the same denominator. Can't I just break them to their own fraction? Ton of h. You're right. But we can break these to their own fractions, which is what we have above. So what they say is sine of x cosine h minus 1 all over h plus cosine x sine h all over h. And then the very last step, because it's fractions, and you can divide, you can multiply to a fraction, or you can multiply across the tops and then divide by the bottom denominators. What they did was, they go and say, isn't that the same as if I took, whoops, and moved and said, hey, cosine and sine are out front. And now you have what we have above. So again, this is going to help us take a sum of a sine and a cosine, create a sine equation, or just in one trig function. So our problem is 3 sine x plus 4 cosine x, right in the form of k sine of x plus, I changed it to an empty set on the bottom. I'm not exactly sure the name of it. I'll have to look that up. So, k is equal to a squared plus b squared, take the square root. That's not too bad. So k equals the square root of 3 squared plus 4 squared, which equals the square root of 25, which equals 5. So now you know your k value, and at that point you're like, hey, that's a vertical stretch of 5. And then we can go to cosine of that symbol, which we'll have to look up here, of 3/5. Wait, how did I know that was 5 right away? It's the K value. And we should also look up the fact that it's sine of 4/5. You take your calc. No, you gotta find that angle. Once you find the angle, you find out it's somewhere about 53. Take the inverse sine and inverse cosine. You guys can finish the rest of worksheet 3. Oh, sorry. So 5 sine of x plus 53 is your answer. And you guys should be able to graph that. Vertical stretch of 5, phase shift of 53 degrees to the left. Have a great day.